All right, so today we're going to look at inverse relations and functions. Okay, so when we talk about inverses or inverse relations, not necessarily a function, but inverse relations, what is the inverse of a relation? It is a relation that exchanges x and y and is a reflection in the line y equals x. Okay. So if I have, as far as notation is concerned, the inverse of relation R, so it's like a capital bolded italic R, the R inverse. Looks like R to the -1 power, totally not to the -1 power. All right, so it says we're going to give the inverse of relation R below. So here's relation R. Our inverse then would be, we're exchanging x and y, so this becomes a -7, 0 to -1, -2, -4, and, oops, 3, 6, not 6, 3. 3, 6, okay? So there's the inverse. Now, we really focus more on functions, okay? So the same stuff is true if it's a function, but we have to look at what's called a one-to-one function, right? So a function has a one-to-one relationship if the relation and its inverse are functions. Okay? So a function has a one-to-one relationship if the relation and its inverse are functions. Okay? One-to-one. So it works along the same lines as like the vertical line test. So it says recall. Recall meaning we already know this. Recall. The vertical line test is used to determine whether a relation is a function given a graph. So then we have the horizontal line test. Okay? It's used to determine whether the inverse of a relation is a function. Okay? So the vertical line test determines if it's a function given a graph. The horizontal line test determines whether the inverse of the relation is a function. Both the relation and its inverse, relation and inverse, must be a function in order to have a one-to-one function. Okay? So, for first let's just look at 1 through 6. Are all of 1 through 6 actually functions? Okay, so let's just do that part first. So, is it a function? Yes, it passes the vertical line test, so that's a function. This passes the vertical line test, so it's a function. This passes the vertical line test, so it's a function. This is a function. This is a function. Okay? And then this, not a function. So if I'm trying to determine whether the relations are one-to-one function, the answer is no on this one for sure, because it's not even a function to begin with. 1 through 5, they're functions. So in order to be a one-to-one function, not only does it have to pass the vertical line test, it also has to pass the horizontal line test. So on number 1, okay, passes the horizontal line test. Works just like the vertical line test, so the answer to this one is yes. It's one-to-one. This one does not pass the horizontal line test because it's going to intersect a whole bunch, so that's a no. 3. Okay, this passes. Remember, this isn't actually horizontal, so it passes. So this is yes, one-to-one. Then number 4. Yep, so this is yes, one-to-one. and then 5? The answer is no, because if I put a horizontal line right here, it intersects an infinite amount of times, so that's a big fat no. Okay? So for the inverse, to be a one-to-one function, you have to pass the horizontal and the vertical line test. All right, so let's talk about inverse functions here. This is the notation. Okay, this is important. So we talked about inverse relations. Now we're talking about inverse functions, and we focus mostly on functions here. So the inverse function of f of x is written as f inverse of x, like so. Not all functions have inverse functions. To find the inverse of a function, we replace f of x with y, interchange x and y, and solve for y. And then we rewrite y as f inverse of x. Okay. So let's look at number 7. We are going to set this equal to y. All right, we'll take off that f of x, make it equal to y. Then we're going to exchange x and y, so this becomes 4y minus 8 equals x. And then we solve for y. So this is going to be 4y equals x plus 8 divided by 4, so y is equal to 1/4 x plus 2. So that means that f inverse of x equals 1/4 x plus 2. Right. So let's look at number 8. We've got f of x equals this, so this is going to equal y. I exchange them, so I get 1/2 y cubed minus 1 equals x. Add 1 to both sides. Multiply both sides by 2. So I get y cubed equals 2x plus 2, because I've got to multiply them both by 2. Then I'm going to take the cube root. So y is equal to the cube root of 2x plus 2. So then f inverse of x is equal to the cube root of 2x plus 2. Okay? Because this is a cubic, the inverse of a cubic is the cube root. So let me show you how that works here. So here is my line y equals x, because remember it said that we're going to reflect in the line y equals x. So there's my y equals x. And here's my x cubed. Okay, let me zoom in a little bit. Okay, there's my cubic function. If I reflect it in that line, I get the cube root of x. I can take this one away, and there's your cube root. There's your cubed. So there's your reflection in the line y equals x. Okay. Let's go back to this. All right, so I have number 9 here. All right, sorry, got interrupted there for a second. So got this, I'm going to this equal to y. So this gives me y minus 4 squared plus 6 equals x. So I'm going to subtract 6, so I'm going to get y minus 4 squared equals x minus 6. Then I'm going to take the square root of both sides, so I get y minus 4 equals, so this is going to be plus or minus the square root of x minus 6. So then y equals plus or minus the square root of x minus 6 plus 4. Now, let's think about what's really happening here. This is a quadratic. Okay, so if I think just about my parent function, this is the quadratic. Okay. Then, if I reflect that in the line y equals x, let's see what happens here. Okay, so let me take these off. Here is my quadratic. If I reflect that in the line y equals x, I get this, the green one. So is that, if we just look at the green one, is that a function? The answer to that is no. So, because it doesn't pass the vertical line test. So a parabola actually doesn't have an inverse. And if you look at what I have over here written out, this is plus or minus, because when I take the square root, that's what happens. That's why your parent function of a square root curve, that is just half of that parabola. If I only use the top half, then it is a function. Okay, so over here, and I'm working these like y'all work them on purpose, by the way. It says determine if f of x has an inverse. If yes, find the inverse. Well, if you actually think about what these graphs look like before you jump in and start doing this stuff, then I would know before I even did this part that this is going to give me something that looks like this. Obviously not exactly the same because it's not the parent function. It's not even going to be a function. So I didn't even have to do any of that. And my answer is just no inverse function. And my reason is that it fails the horizontal line test. If I had taken the time to draw the picture, which I know most of you don't, that's why I didn't and jumped ahead here, then I draw this picture, has the vertical line test, fails the horizontal line test, because this would fail. So I didn't even have to do all that. So back up here, had I thought about that, this is a line that's not vertical, so it's fine both ways. And again, this is a cubic, and so it's going to pass the horizontal and vertical line test. Right? So number 10, we're not going to do because we haven't done the rational functions yet. That was one of the parent functions I've skipped. So let's move on to number 11. So let's think about this. Parent function is a square root curve. Does that pass the vertical and the horizontal line test? And the answer to that is yes. So I can work through this one. I'm going to change this to y. So I'm going to get negative square root of y plus 2 minus 7 equals y. So then I'm going to add 7 to both sides. So I get negative square root of y plus 2 equals, oh wait, shoot. I don't have an x anywhere. Sorry about that. This should be x. Why do I have two y's here? Sorry about that. I only switched one of them. So this has to, if I'm going to switch that one, I got to switch this one too. There we go. So this is going to be negative y square root of y plus 2 equals x plus 7. So then I'm going to square both sides to get rid of the square root. That's going to leave me with y plus 2 on the left equals x plus 7 on the right squared. And that's not x squared plus 49, and I don't need to square it out. So now I just need to get y equals x plus 7 squared minus 2. All right, that means that f inverse of x equals x plus 7 squared minus 2. All right, so now we've got to think about this. This is the square root curve. This is a parabola. And we know that that's a parabola. So something's weird here. Here's what this says up here. State any restrictions on the domain. Okay, so let's think about our original function. Our original function here, right? I want to know what the domain and the range is here. So it might be helpful to kind of get a good idea of what this function even looks like when I actually graph it. If I'm going to have this function that looks like this, and first of all, that negative means that I reflect it in the x-axis, so it's actually going to curve down, right? I'm going to go to the left 2 and down 7. So it's going to curve like this about, okay? And I went to the left 2 and I went down 7. So my domain means that I'm going from negative 2 to infinity. And my range, I'm going from negative infinity to negative 7, right? So restrictions on the domain. This is my original. This is my domain. This is my range. Let's think about how we got here. We got here by exchanging x and y. The domain is my x. The range is my y. So I need to exchange my domain and range. And when we do the restrictions on the domain, we've really been doing it in set notation, or it makes it a little bit easier. I know that I need my domain here, okay, because remember, this is the domain and range of the original one. These two trade places, just like X and Y did. Restrictions on the domain is that the domain is only from -infinity to -7. Oops, and I do get to include -7. I should have done that, sorry about that. That's my restriction on the domain. Okay, because when you have that parabola, you're only getting half of it. Up here, these were fine because this was a cubic and a cube root. They're going to have all real numbers, all real numbers. Same thing here. Okay. So let's look at this absolute value function. My parent function looks something like this. Okay. This is why I've been telling you, draw the little pictures and you can get an idea of what's going on in your head. Is this a one-to-one function? Will it have an inverse? The answer is no, because it passes the vertical line test, but it fails the horizontal line test. So I say no inverse function fails horizontal line test. All right, so let's look at 13. 13, this is a cube root. So my cube root function, parent function, looks like this. So yes, it's a one-to-one function. So I can move on then. All right, so I'm going to exchange x and y. This is y. So this is going to give me the cube root of y minus 9 over 4. And that's equal to x. So I'll multiply both sides by 4, so I get the cube root of y minus 9 equals 4x. Then I'm going to cube both sides, so I get y minus 9 equals 4x cubed. And then I'm going to add 9 to both sides, so y is equal to 4x cubed plus 9, which means that f inverse of x is equal to 4x quantity cubed plus 9. So there's my inverse function. Any restrictions on the domain? No. So I want you to think about this too. I have this, which means this 4 is a horizontal compression by 1/4, right? Had I actually cubed this, this would give me, like if I'd actually cubed this here, I'd get y equals 64x cubed plus 9. So then I would have a vertical stretch by a factor of 64. That's actually going to give me the same answer either way. Or the same graph, rather. It graphs the exact same thing, just different ways to look at the transformations. All right, let's look at number 14. Okay, so now I got a parabola, and it says I'm restricted to x is greater than or equal to 0. So this parabola up here, I said, oh, you know what? We really didn't even have to do that because this was a full parabola. But now let's look at what's happening here. If I've got 3x squared minus 1, right, so then really what's happening for my parent function, this is my parent function, and this is just a stretch and a shift down. If x is only going to be greater than or equal to 0, then that means it's really just this part of the function. So that part does pass the horizontal line test. So given this restriction here, I can do this and I can find the inverse. Okay? So let's go ahead and do that. We're going to set this equal to y. Then we change them. So 3y squared minus 1 equals x. 3y squared equals x plus 1. We divide by 3. So I'm going to get y squared equals x plus 1 over 3. And then take the square root. So y is equal to, and there's no plus or minus here because it's just going to reflect down and be the top half. So that's why I'm leaving that off, not because we always leave it off. And the square root of x plus 1 over 3. Well, I can't have a fraction in there. So this is the same thing as the square root of x plus 1 over the square root of 3. And so I'm going to rationalize this, square root of 3 over the square root of 3. So this gives me the square root of 3 times x plus 1 all over 3. And then I can look at that as 1/3 square root of 3 times x plus 1. Okay, that means my f inverse of x is equal to 1/3 square root of 3 times x plus 1. But remember, we have to think about our domain here, our restriction on our domain. So if this right here, if I actually graphed that, then I would have a vertical stretch of 3, but the 0, 0 would shift down 1. So I'd be down here at -1, and then it would be stretched up. And the stretch really isn't going to affect anything. So my domain really is all real numbers, but now we've got this that's just, it's only this part that's being reflected, right? The range here, so my range for the original one is from -1 to infinity. So when I reflect this down, okay, when I do the inverse, then I can't have all real numbers because it's only going to be this part here that gets reflected, right? It's only going to be the top part. So I have to exchange my domain and range here. So here I can say that x has to be greater than or equal to -1, which is the same thing as this. So I have to put that domain restriction in there. The domain and range switch places. This is the original. This is the inverse. Okay? The domain becomes the range, and the range becomes the domain.